Good. All right, Marcel, it's all yours.
Thank you, Dale. And I promised to start with a presentation from Pastel. We had an invitation from the Tech Ops, so we were invited content with a panel for sustainability and mobility. And one of the themes that Tom Strandberg, he's also, I think he is chair for the Swedish chapter, he said, well, let's take a look at a word called pestle. Some people try to write it down as P-E-S-T-E-L, and some write it as P-E-S-T-L-E. Well, what's in the word? Well, it stands for political, economical, social, technological, legal, and environmental. And Carrie took us away and said, well, she brought it in a perspective as a selling point. How do you make your sales pitch? And why should I use Pastel? I will not tell everything from this presentation because we do have a repetition of this one with Carrie on board, and she will do her presentation again. So I will do just the highlights. And one of these Pastel applied means, well, this is one sheet in which he says, well, this is the way we can sell it as transportation. And the main takeaways that she gave us was, well, Pastel is well, you should use it as a tool, but not the only tool. It's a systematic way, and it can be useful for developing long-term sustainable solutions. On the other hand, don't forget that we also invented an acronym called RAMS. Reliability, availability, maintainability, and safety. And there came a lot of letters behind it, security, health, environment, etc., etc., etc. So please note that Pastel is not a target on its own. No, it's a tool to get to your target. So that is in very short what she told us about Pastel. I will not go any further for this because she is the expert in it. I just told what she has told us. My role in this panel was talk about the point of view of a contractor on Pastel. As you can see it, I write it as P-E-S-T-E-L. Well, that's all in the name. And my job was, well, tell it, what does a contractor do with Pastel? Well, I work at a company called Heijmans, and it's this strategy of a contractor is not unique, but our ambition is to create a healthy environment. We want to make it possible that all people live healthy in their environment. One of the things that we want to do is, if we build houses or residential areas, we want to make it more diverse as when we got there. Most of the time once we got there is that we have some agricultural land which has monoculture, only grass or corn or grain or whatever is on it. And when we leave, there are houses, there are several types of trees, lawns, etc., bushes, not monoculture, but as diverse as possible. Also, the people that are living in that environment, we want them to be as diverse as possible. Young people, older people, mixed up. One of the things that we want to accomplish is that everybody wants to have clean air, a nice neighborhood, a safe workspace, and safe travels to commute from A to B, from their living to their work. So that means something for a smart city. At Heijmans, we have also a division called Smart Cities. We have a director. So some of the sheets that I will show do have the logo of Heijmans on it, because it's their intellectual property and I was allowed to tell about it just as long as I show their logo. So my apologies for the advertisement that's on it. But how do we do it? Well, if we want to have a healthy environment, we want to have smart buildings, a smart neighborhood. So it's building up from smart city, from smart building to a smart neighborhood to even smart city. We start with buildings. And how do we do it? Well, we do it with sensoring, and we do it with quality engineered data. Not a vast number of data, but we want to have it engineered, we want to have it structurized, otherwise we cannot make any decisions on it. The next sheet that I will show you, it's on purpose a very small type, because it's in Dutch, but as you can see, 1 to 5, that's the vertical, that's the scale. How smart is a city and how do we measure it at Heijmans? Well, we start with level number 1. Level number 1 is just analyze. Level number 2 is, well, we are able to communicate about what we analyzed. Level number three is, well, we connect. Level number 4 is, well, we support the environment, and level number 5, well, we are able to get optimizations. And we do it on various focus areas, and those are in the vertical columns. Some of them are data. I will start with the first column. In Dutch is verklaring, which means definition, meaning of something. Then the second is strategy. The third column is called organizations. The fourth is services. The fifth is technology. And the sixth one is data. So we have a matrix, and we can score that environment and put a dot in that area. And that's how we define how smart a building, a environment, or a city is. So a little bit deeper dive into that level. On the analysis level, we are only able to censor. So we censor air quality and we just collect data. And we see it's 21 degrees centigrade, so okay, it's 21. We do not do anything with that value. We just see it's 21. We don't add value to it if it's good, high, too low, or whatsoever. So the next thing that we do is communicate with the inhabitants. Well, we say, well, we have censored the air quality, or we have censored the temperature, and it's 21 degrees, and we advise you to keep the doors closed, otherwise it gets too hot. And the third one is get a connection. So then we are trying to put that analysis and that communication not just to people, but to systems. That open or close windows, or start heating or start cooling. And then the next level is supporting. Well, the system takes over on that level and takes external factors into account, like it's no use opening a window, even it's very hot, when it's raining outside. So it's helping you to make the right decisions on the right moment. And the most high level that we see is the optimal level, and then it's proactive, like artificial intelligence, and the system predicts what's going to happen. So in the morning, it says, well, it's wise to open the windows right now to get cool air into this house. Then later today, it will be very hot, because the predictions are that it's going to be 35 degrees centigrade, which is, I think, about 100 degrees Fahrenheit. So I open up the windows early in the morning, then it's cool. And when it's getting hotter, I will close the windows myself and then start cooling the whole building. So that's optimum. Proactive. And at Heijmans we have what we call a focus area wheel. So everything that we measure and everything that we do has some area of special interest, special focus. I will not go very deep into this, but on the most outer part, you see that there are some other areas like smart, healthy, well-being, smart building, smart energy, smart environment, smart infrastructure, smart mobility, smart governance. And as further as you go in, you come to the core of this model, and that's the healthy environment. In Dutch, gezonde leefomgeving. That's the yellow part of this. And we have this in 3 domains, which is the nature domain. We have the spatial domain, and that's for transportation and mobility and economic value. And we have the social domain, which is the people that are in it, energy, circular, green and blue around your house. So I will skip a few of these slides of me. So what about decisions? Well, we have a division. I'm part of that division, and that's called design and engineering. And we have some kind of a strategy about data. And this goes well with the earlier mentioned levels of being smart as a city or as a building. And here you can see we call it our rocket, that we are putting data in a source. We have centralized sources. Then we go to what we call some kind of a single source of truth. That's the light blue one. And then as soon as we get that level, well, we start really to lift off. Then we gain some traction. Then we can get decision support or submitted decisions or automated decisions or predicted decisions. Well, predicted decisions, artificial intelligence, if you have the right data, engineered quality data, then you can go to the predicted decisions or automated decisions. Otherwise, you're making decisions automated based on rubbish data. And rubbish in is rubbish out. Some examples on that wheel that I just mentioned is what we call social interaction. When we create areas, we want to get connected, and we want the people in that area to be connected, and we want to be in that area for as long as possible to make sure that the people are getting connected and have a good conversation what they want to do with their environment. We used to be a traditional contractor, get in, build as fast as possible, make as much money as possible, and get out as quickly as possible and hand it over to the client. And well, client, this is what somebody asked me to build for you. Here's your house key. Good luck with your building. That's not anymore our business. We want to make sure that the client is happy so that he comes back if he wants to make some renovations or wants some things added to his building. So we want to also be involved in safety. Many of these residential buildings are in residential areas, which means no industry around, just living. We don't want people to rush in those streets, so we have to make sure that it's safe for children to play in those areas, or the older people, that they can go safely on the sidewalks or on the streets, not getting crossed over by cars. Which brings me to a very special invention that we made, which is what we call Bike Scout. And we tried to push this invention as a technological invention. What is Bike Scout? It is a warning system for motorists or car drivers to warn on level crossings for bikers that are crossing your level crossing. We have many bikers in the Netherlands, cyclists, and sometimes we get very serious accidents between cars and those cyclists because cars do not always see those cyclists. We made an invention that the car driver actually can see that a cyclist is approaching the level crossing. There are some lights flashing into the road, and as soon as those lights start flashing, the automobilist, the car driver gets warned, well, there's a cyclist coming from the left side or from the right side, so let me wait for a few seconds and then it's safe for me to cross the level crossing. We try to push that and sell that to municipalities. They didn't want it. And we were astonished that they didn't want it, because it made the environment a lot safer. And in a certain moment, we got a call from an insurance company, and they said, well, we want it. And we are willing to invest in it, because if we invest in it, it's going to deliver us a lot of money, because the cyclists don't get overrun, so they don't have to be treated in a hospital or by a doctor, so that saves us money. The car doesn't get damaged, the bicycle doesn't get damaged, so this is going to deliver us a lot of money. So please, we want them to be installed on that crossing, on that crossing, on that crossing in those cities. So that was, for us, some kind of an eye-opener, that we don't always have to push on the technological improvements, but we have to look at the safety and the social improvements. Hey, there's PESTEL again, social environment. This is also a thing that we want to achieve. We want to create environments for different audiences, well, diversity, young and old, cyclists, pedestrians, all should live and move together in a way. And not everything has to be a building. It might sound strange for me as a contractor that we also build trees. We plant trees, we plant bushes, etc. Not just buildings. We do the whole residential fill-in. The biodiversity is our job also. We have some people who are specialized in biodiversity in our company working, so that when we are arriving and developing such a residential area, they can make sure that the biodiversity in that area is okay. Another thing about PESTEL environments, many cars in the Netherlands now being sold are electrical cars. As you know, the electrical grid is not sufficient to charge every battery from every car every night. So what we try to do is have some local energy factories like solar panels, and they will make it easier for the grid for charging everybody's electrical vehicle. And they want to create a kind of independence from the grid. And of course, we want to be CO2 neutral. One of the last things that I want to mention is about circularity. We have what we call a materials passport. Again, this one is also in Dutch, but what we see is we have apologies, my dog is a little bit hyperventilating. Come here.
Is he okay, Marcel?
Yeah, apologies, my dog was hyperventilating.
I tend to do that about this subject too, so I understand.
Again, about circularity, what we do is when we build buildings, we want to make sure that we know where the materials are coming from, what the destinations are, and how they are being prepared and how they are stored in that building. So if later on in the new life cycle we want to destroy the building, renovate the building, then we can literally harvest this building and reuse the materials exactly for the same purpose as we installed them. And of course, one of the things that we want to do is have some economical value. It's no use to build a house for, let's say, $100,000, and the moment you have sold it, the value of that house will be less than $50,000. So you have to make sure that if somebody is investing in that healthy environment, that its economical value will be stable. And one of the last things that I wanted to mention is mobility. Well, mobility is in need. As I mentioned, this is a residential area, so working in that area will be mostly impossible unless you are some kind of a consultant and do some working with teams like we are talking now. But if you want to do some production work, that's impossible in that area, so you have to commute. And we want to make sure that mobility is available there for the people who need it. For that, I want to conclude my presentation for now. I want to hand it over to Dale. Where's Dale?
Sorry, something weird just happened. IT just did something to my machine. I lost Zoom for a minute, but I'm back. Thank you, Marcel. That was great, and I hope your dog is okay.
Yes, he's a little bit better right now. Thank you. My apologies for this.
Oh, no worries. Totally understand. So I'm going to just whip through. I was intended to be on the same panel that Marcel had described, so I'll be able to go through my slides rather quickly, and we'll try to leave it open for some discussion. But I got sick. I flew to Hawaii and then got sick, so I wasn't able to present this, but I will make an effort to go through this quickly. Good news is I will stop at every slide so that if you want to see it, you can see it on the YouTube channel. You can pause it and read the slide if it's of interest, special interest. So we'll start. Just need to share my screen here, and off we go, hopefully.
By the way, we nicknamed this panel into the Tom panel. We had 3 Toms in this panel. Tom Strandberg, Tom Lusko, and I've forgotten his third name. He was from Australia.
Oh yeah, that's right. I watched the recording of it. So let me just go and can everybody see my screen? I hope. Tom, can you see it?
Yes.
Or Marcel, sorry. I'm so used to saying Tom. Great. So yeah, so this was a position paper from the TWG, the Transportation Working Group, which is a international working group within INCOSE. I won't go through the PESTLE framework. This was done to kind of show a bit of a traceability, if you will. I was trying to show traceability to each slide, to each of the elements in the PESTLE framework. I won't go through explaining what that is, because Tom did a good job of that. So I'll just jump right in. So the idea here is there's a lot of change happening, and there's a lot of solutions being put forward. Maybe before the problem is particularly well understood. We as engineers and just as humans, sometimes we're kind of trained to see if we can provide solutions, to fix things. Engineers like to fix things. If you're not an engineer, you're still a human, and you want to be able to make things better. So you're thinking in terms of solution space, maybe a lot more than you are in problem space. And it is a bit of mental gymnastics to kind of retrain your brain to move backwards into problem space. But these are some examples of things that have happened and are happening. So there's, the transit operated rideshare is an idea. There was discussions. It was actually at an INCOSE conference, I don't know, 4 or 5 years ago, where the private vehicles may not be the thing, that far into the future. So some of the big OEMs are looking at just leasing to quote unquote fleet owners. We've already had some evidence of microgrids showing up, and that's a bigger discussion. Rideshare just happened. It was kind of a solution, followed by the problem analysis later. Like once it's there, okay, well, how does this work with all the traffic and airports and everything that's already in our infrastructure? How do we integrate it after the fact? Bus rapid transit versus rail. That's a big discussion in places. Different fuel or propulsion systems, with fuel cells, both stationary and rolling. The stationary would tie into the microgrids. So those are some of the solutions that are, swirling around the organizations, and some of the mega trends that are happening. The pandemic kind of increased some of them. We've got remote working, remote healthcare, and remote shopping. So goods and services are moving or coming to people as opposed, to people having to go to them, which obviously impacts transit, public transportation. And then there's the realities of our world. The fares don't cover much of the costs. Ridership is still low and falling in some areas. I think it's kind of stabilized a bit, but it's not what it used to be in most places. Infrastructure is getting old, and we don't have great wages. I worked at a transit agency as an indirect employee for 5 years, and I know all about that situation. There's competency gaps. There's a lot of disciplines that are maybe missing completely at a transit agency. Again, they don't have a lot of money, so they can't hire every discipline, and generally have to sub that out. And there's very little interest or awareness of early life cycle activities because people just want to get on with the job. They just want to start. So that's a reality in the field. And really, a lot of organizations are just struggling to keep the buses and ferries and state of good repair, keep everything running. Keep the Hudson Tunnel from flooding, that kind of stuff. So there's what we're proposing in the system lifecycle subcommittee is really sort of over and above that, and to try to help prevent this stuff from happening. And everybody's familiar with with this use case, or this business case, I should say, how California High-Speed Rail. I won't go into it all here, but there's some interesting quotes from some of the former CEOs, 3 of them actually, and some of the political compromises that were made. So that, of course, pulls in the P in a big way from Pestle, maybe too big of a way. So that's, so why is this happening? And why are we having so much trouble building infrastructure? And the answer to that was there's a lot of this early life cycle stuff that isn't happening, or at least it's not happening in a timely way or a completely fulsome way. So there's a lot of deliverables and things that are supposed to happen way back at the concept stage, but those are pre-designed and there's not really any budget for them. So it's less interesting to designers or the PMO. So typically a lot of this stuff just doesn't happen. So the net result of that is that the project planning phase is generally oversimplified and gets very compressed. So the current trends, there's very minimal. We talk about stakeholder engagement all the time, but that's often minimized. Project goals and objectives aren't really fully defined. Sometimes they're a bit mushy. Timescales to do all this are either 0 or very low, because they're, again, it's not necessarily budgeted. And then sometimes there's a complete mismatch between project class. Like if you're creating a design build project and you put it out on the street in an RFP, but you don't actually have system requirements, then it isn't really a design build project, because you end up with crazy things like you're giving 22,000 so-called system requirements to an OEM that has a commercial off-the-shelf system that you're asking them for, service proven technology. So it doesn't make sense. So we're trying to help with that. So, and we mentioned this earlier, that there's very low activity in some of these early concept stages. And so what you see is project teams get mobilized on the same as last project. Let's move forward. Let's not waste a lot of time on it. You always get into this nightmare of at NTP plus 30 or NTP plus 60, you end up generating dozens of planning documents, which, right after they're presented and may or may not get accepted, they immediately go and sit on the shelf and nobody opens them again, sadly. And I've seen that on far too many projects. The systems analysis, all that early stuff, the requirements, the architecture aren't really adequately budgeted and they get left behind. And this one really is a pet peeve of mine, is where we assume that things like a configuration management tool or requirements management tool, something is, you would think in this century, as simple and basic as document control and review and approval processes are all assumed to be operational within days of notice to proceed. I haven't seen that yet. And if you think of some of these mega projects where you got 20 or 30, suppliers, maybe 2 or 3 primes in a joint venture, you're really forming a small company, or actually not a small, a medium-sized company to deliver this project. And yet you don't have a harmonized, all the framework stuff, all the background, the foundational things you need, like document control, configuration management, to make all the cool stuff we talk about in systems engineering actually work. So yeah, I won't go through this. It's kind of a repeat. It was just meant to be dramatic, and it's got some automation in it. But a lot of times, what happens is the summary of it is you get to a situation where events overcome, plans, and you end up blowing through stage gates because of political pressure and various other reasons that are listed here. So you end up with, the system isn't accepted. You get massive change orders, you get missed functionality, or it's very difficult to maintain because they forgot to talk to the O&M people. And this is actually right out of the INCOSE handbook. So this is the older version, actually 2 revisions ago of the handbook. Version 5 is out now. So even back then, the INCOSE folks had it figured out. And I love this. Many projects are driven by eager project champions who just want to get on with it. And that's the people part of the equation of people, processes, and technology. But if you do that, it's a little bit insane because, or at the very least reckless, because if you scrimp, if 70% of the life cycle cost is locked in those early phases, and the opportunities to make new decisions or reduce costs for the life cycle, it's kind of reckless to scrimp on that first small percentage. So one of the answers that I've seen recently is what I call the procurement silver bullet. Just stick a statement in your 17 volumes of procurement papers saying the supplier shall comply with ISO 15288. And that just does absolutely nothing. And I've had conversations with big civil constructors, and how are they expected to even know what the heck that is, and how do they deal with it? Well, the answer is they don't. If this quote at the top, we've been building roads, tunnels, bridges for thousands of years, we don't need this, somebody else deal with it. And that's what happens is they sub it out. It becomes a tick box exercise, or they ignore some of the system lifecycle processes. They get steamrolled over by design, which sort of is driving everything instead of the other way around, or they negotiate most of the budget away anyway during best and final offer, or any combination of the above. I've seen many combinations. So the theme is, and again, we're still exploring the problem space. The poor or missing requirements equals project failure. There's international studies on that with sample sizes of 50,000 projects. The Standish group does a thing they call the KS report, and they have a very large sample size, and it always comes back that poor and missing requirements cause projects to fail of all sizes. They do small and mega, all the way up to mega projects in their study. So decades of transit evidence is available too. So there's this thing called accountability fade that we've identified, where you've got a mismatch between how people are rewarded personally and on a project versus the length of time it takes to actually execute a project. And when that happens, there's you get this disconnect. So if you've got staff rotating every 1 or 2 or 3 years, but the project's lasting 10, 15 years, the accountability starts to fade. So this can't continue. We need to do something about it. That's the whole point of the MOU between the American Public Transportation Association and INCOSE. The expectations of public transport are high, and they're getting higher even with the younger generation. They're expecting more and more out of public transit, more connectivity and less of the old school sort of thinking, if you will. So what are we doing? We are working with APTA, that I've already mentioned. And of course, INCOSE as a body has an agreement with the PMI. So that's fantastic. And we're extracting that shared knowledge. And Marcel's already mentioned the Smart Cities Initiative, which has obviously there's a heavy transportation component in consideration of a smart city. And of course, we work with within INCOSE with the infrastructure working group as well. And also not as successfully recently, but we're going to try to reach out to SIPR, which is the critical infrastructure working group. So there's a lot of horsepower at INCOSE. So just jumping quickly to APTA, we've renamed it from the Systems Engineering Subcommittee to the System Lifecycle Engineering Subcommittee to try and remove ambiguity in the conversations. And it's having a positive effect. It's catching on very quickly within APTA. And we're not pushing that on the INCOSE crowd yet, but we are starting to hint at, we need to look at our branding a little bit as far as the word, the phrase systems engineering. So our mission with APTA is to engage with the stakeholders across the full life cycle, not just, basically cradle to grave, and figure out how to include the right stakeholders at the right point in the life cycle, and make the projects more successful. And the way we do that, or are going to try to do that, is to across a generic life cycle. This is the IEC version, which is pretty hard to argue with, because you have a concept, you develop it, you produce it, you use it, you support it, and then you eventually you retire it or rehab it. So our mission is to at the subcommittee level is to really help competently deploy these processes across the entire life cycle. And I apologize, I'm going really fast here because I want to leave some time for discussion. So we have a proposed life cycle which is still in flux, and what we're doing is we're looking to work at the very early stages initially, because we think that's where we can make the most impact and certainly the most life cycle cost impact. So actually design the project and actually design the procurement. Don't just do same as except. And then of course, then you do get into procurement, and there's some different things, some interesting things we can talk about there. There's actually a technology procurement working group, if anybody's interested, that our subcommittee is helping at APTA, which also, again, will pull in INCOSE folks. And then last but not least, the summary, we're working with APTA and external groups to generate a practical standard. I forgot to mention that earlier. And its member transportation agencies, which are actually asking for this at this point. They're looking for a standard because they don't want to keep doing business the same way. They need the help. And we're here at APTA and INCOSE to help them. And then there was some interesting discussions at the end of one of the panel that, and Marcel hinted at this, that PESTEL is one acronym, but there's also things that we need to consider. And I think we do a decent job, but we can do better with, diversity, ethics, and quite frankly, civility. I think that's one of the big ones that gets overlooked as far as an ILIT goes. We really need to try to improve civility, and that ties in with stakeholder engagement and not sitting across the table at some people and glaring at them, but trying to really work with them in a positive fashion. So that's what I was going to present so I presented it now. So I will stop this and we will carry on with our discussion. So I'll just open it up for discussion now. And I'm going to stop the video here and stop sharing. No, I don't need to do that. Stop share. So yeah, how are we doing for time? We got about 4 minutes left. So comments, just open up the floor if anybody wants to say anything. Sorry, I had to go through it so fast, but I just wanted to give you a flavor. And the same with Marcel. There was four people on that panel, and Marcel was able to summarize briefly one of them. So we'd really like to, re-engage with that panel again, and do another run at this. Because we all think it's an important topic. So I'll stop talking and let you guys talk.
So Dale, hey, this is Steve Kang. So I have a question for you. One of the charts you presented, engineering teams or organizations are skipping the gate reviews, for a variety of reasons. What is the enforcement mechanism? So what I've seen is if you're going to set out a requirement through an RFP or, whatever contracting mechanism, that becomes an agreement. However, on the acceptance or the testing side, there has to be an enforcement of that requirement. So how is that being applied in the industry today?
So that's a really good question, Steve. Thanks. So there's actually a quality in systems engineering working group that's relatively new, just a couple of years old. And one of the quality managers from the Apollo program, sort of kicked it off because he's very passionate. He's a guy that's, he's actually met Deming and talked to Deming, and really that's what's missing. And there's a quality fade that's happened. Quite frankly, not, this isn't just a rail and transit problem. This is a global multi-country problem where quality has faded. We did the whole quality thing. If those of you that are old enough to remember Six Sigma and Six Sigma black belts and Lean Six Sigma, I went through all of that at General Motors and got my black belt. But a lot of that stuff that was 20 years ago or so. I'm dating myself. That's faded. There's a lot of managers at various levels in organizations that have kind of maybe forgotten a bit about those lessons that we learned. And I think that's what's missing. And that to me is the root cause of, people are people. They'll get away with whatever they can, especially depending on how they're rewarded on a project or in their role at a company or an agency. So if there's nobody there to sort of help enforce these policies, you just get things like, where the project management, they make a decision because they have their role, they're rewarded for progress and milestone payments, and they've got political pressure on them. So if there's nobody who is sort of separate and distinct from all that, like the way we have the independent safety assessors on all these transit projects, QA should be in that same, that's an assurance role. Well, quality assurance should in theory exist to do the same thing, but in a more general fashion. So anyway, sorry, that was a long answer to your question.
Can I add something to that one, Dale?
Oh, please.
Well, I'm experienced in Europe, in the Netherlands, and in the UK. Also another thing, and that is some kind of a cycle. Nowadays, the agencies, the Transportation Ministry in the Netherlands, has pushed a lot of knowledge and a lot of their own knowledge into the market. So many of the people who know how to build bridges are no longer working for the Ministry of Infrastructure. The same goes for England, for the UK.
Yeah.
So they don't know how to enforce what's good or what's bad, what's good quality or what's bad quality. They rely on their processes and on process management. And now we see the cycle going backwards and say, well, this was a little bit of too much knowledge that was going out of the gates. And so they are acquiring new people with new knowledge about how things are properly built again. So the quality assurance is coming back.
Oh, that's good news.
At least for the Netherlands, it's coming back. It's going slowly, but it's coming back.
Yeah, that's a really bright spot to possibly end on, because mine was a bit gloom and doom, and I apologize for that. But I'm just trying to present the reality, at least here in North America. But we can always do better, and that's fantastic, Marcel. Any other quick, just trying to respect everybody's time. I guess we're a minute over, but anybody other quick discussion points? And okay, well, hearing none, we talked about the IS coming, the deadlines coming up for IS, and also the deadlines for APTA are much further out, but time to start thinking about if you want to present a paper at APTA, we're happy to help and guide and make some of that stuff happen too, because I think that's an important venue, and we are really trying to reach, back and forth between APTA and INCOSE to make this a better and more wholesome discussion. So I guess thank you to everybody that took the time to attend, and as Marcel mentioned, we'll try to do a more and maybe it'll even be sort of a 90-minute or a more fulsome discussion where we can get more more back and forth discussions with the panelists. But I really appreciate everybody coming out.
Well, thank you for the invitation, Dale, and the rest of the Transportation Working Group. It was an honor and a pleasure to be here.
Thank you. Thanks, Marcel. All right, well, I'll stop the recording then.
Thank you.
And I think we're good.